Hello. In this video, we're going to be talking about right triangle trigonometry and how to use it to find missing sides and angles of right triangles. In any triangle, you've got three sides and three interior angles. In a right triangle, you always know one of the angles, the 90-degree angle, which is normally marked with a little square in the corner. So let's do some examples. If we're given two angles and we want to find the third angle, we're going to use the concept of the sum of the interior angles equals 180 degrees. So in this example, we know that angle B is 57 degrees. Angle C is our right angle, so that's 90 degrees. And we want to find angle A. So all we have to do is set up an equation that says angle A plus angle B plus angle C equals 180 degrees. We know angle B is 57 degrees. We know angle C is 90 degrees. Sub those in and solve for angle A, and you get 33 degrees. Okay, so what happens if you have two sides and you want to find the third side? Well, in that case, you're usually going to make use of the Pythagorean theorem. So in this example, we have the hypotenuse equals 14. So I'll just call that C equals 14. One of the legs equals 9. So I'll call that leg A. And then the other leg, we don't know what it is, so that's B. We don't know that one. So we just set up the Pythagorean theorem, A squared plus B squared equals C squared. We sub in 9 for A. We sub in 14 for C. And then we solve for B. So we end up with B equals the square root of 115, which I found a decimal approximation for and rounded to one decimal place and got 8.3. So we found side B equals 8.3 units. Now, what happens if we're given one side and one acute angle and we want to find an unknown side? Well, in that case, we're going to make use of the trig functions, the sine, cosine, and tangent functions, which are defined in terms of ratios of two sides of the right triangle. So in this example, I've got an angle measured 40 degrees. We've got a leg of the right triangle at 7, and I want to know what the length of the other leg is. So what you want to start out with when you do one of these problems is label your sides by labeling each one either hypotenuse, opposite, or adjacent. So opposite the right angle is the hypotenuse. Opposite the angle that we're using, the 40-degree angle, that's opposite. And then adjacent to or next to the 40-degree angle, but not the hypotenuse, that's the adjacent side. So we've labeled all of our sides. So what are we working with here? We've got an angle, we've got an opposite side, and we want to find an adjacent side. So we need a trig ratio that uses opposite and adjacent. So when I look at the three options I've got here, I'm going to use tangent. So I set up a little equation that says tangent of 40 degrees. We know that equals opposite over adjacent. Opposite is 7. Adjacent is the unknown, so that's x. So now all we have to do is solve for x. So I'll multiply both sides by x. And now I just have to isolate x by dividing both sides by the tangent of 40. And now it becomes a calculator problem. So just a couple points on your calculator. Make sure you are in degree mode because we're working with 40 degrees. And punch it in. And then I'm going to round this to one decimal place. So I'll write x is approximately equal to 8.34, one more than the number of decimal places I want. Look to the right. That's not 5 or greater, so I don't round up. So my answer is 8.3, rounded to one decimal place. Okay? Let's try another example where we're given one side and one acute angle, but we're going to do a little bit different form here. In this example, I want to find the horizontal and vertical components of a force vector with a magnitude of 150 newtons and an angle of 38 degrees. So if you've worked with vectors in your physics classes, you'll know what I'm asking for here. If you're not, don't worry about it. Just focus on the right triangle portion of the discussion here. So I'm going to draw this vector. So at 38 degrees to the x-axis, I'll say that's about this. There's my force vector. The magnitude is 150 newtons. And the angle was 38 degrees. So all I'm going to do is I'm going to draw a line segment from the tip of the force vector down perpendicular to the x-axis. Okay, so what have I done? I've created a right triangle. So now let's talk about these horizontal and vertical components of the vector. So the horizontal component is right here. It's on the x-axis there, so I'll just call that x. And here is the vertical component of the force vector right here. So basically, all we're looking for is to find x and y. One side of a right, well, actually two sides of a right triangle where we know one side and the angle. So let's work with the horizontal component first, which we're calling x. So what am I going to do here? Well, relative to 38 degrees, let's label all the sides of the triangle. Relative to 38 degrees, the side opposite is my y side. So I'm going to label that opposite. Here's my hypotenuse, which is opposite the 90-degree angle. And then adjacent to 38 degrees, or next to the 38-degree angle, is my x side. So I've labeled all my sides. So if I want to find x, what am I going to do? I'm going to focus on adjacent and my known side, which is the hypotenuse. So I need a ratio with adjacent and I have hypotenuse in it. So that's the cosine. Okay? So my equation then is cosine of 38 degrees equals adjacent, which is my unknown, over hypotenuse, which is 150. Now all I have to do is solve for x. So I'll multiply both sides by 150. Punch this into my calculator in degree mode, and I get something. I get x equals 118.2 newtons. And let me change that to approximately equal. So I've rounded to 1 decimal place. Okay, we're going to do the same thing for the horizontal component. Pardon me, the vertical component. And that we labeled y. So I'm still working from the perspective of a 38-degree angle, so all my side labels stay the same. But what am I looking for now? I'm looking for a ratio of opposite, my y, and hypotenuse. So I go up to my 3 trig functions here and look for something that has opposite and hypotenuse in it. Well, that's my sine function. So I'm going to set up an equation that says the sine of 38 degrees equals opposite, that's my unknown y, over hypotenuse, 150. And now I just solve for y. So I multiply both sides by 150. Stick it into my calculator, and I get y is approximately equal to 92.3 newtons. Okay? So now we've used right triangle trig to help find the vertical and horizontal components of a vector. All right, let's change tack a little bit here. Let's say we're given 2 sides and we want to find an angle this time. We're still going to make use of our trig functions. So in this example, I want to find theta, and I know 2 sides. One's labeled 4, one is a leg of the triangle, and the other leg of the triangle is labeled 5. So again, we're going to start by labeling everything relative to the angle we're worried about, which in this case we don't know what it is, but it's theta. So let's label our sides. So opposite the 90-degree angle is the hypotenuse. Opposite theta we call opposite, good name. opposite or adjacent to theta or next to theta. We call that adjacent. So what am I looking for? I'm looking for a trig ratio that involves the two known sides, opposite and adjacent. So if I look up here, that would be tangent. So the equation I set up is tan theta equals opposite, which is 4, and adjacent, which is 5. Now, look where theta is. It's buried. It's input into my tan function. So what I'm going to need to do here is use the inverse tangent function to get at theta. So I'm going to take the inverse tangent of each side of the equation. So the inverse tangent of the tangent gets me to theta. Then the inverse tangent of 4/5 is the right side of my equation. So a couple notes, this -1 here, the -1 superscript, that means inverse tangent. Sometimes you'll hear it called arctangent, but that means inverse tangent. It does not mean reciprocal. This is not an exponent. It doesn't mean reciprocal. It means the inverse tangent function. So again, we're into calculator mode here. So 2 points. We're going to solve for theta in degrees. So you're going to need to make sure that your calculator is in degree mode. Then you're usually, on most calculators, you're going to enter shift tangent, and then the shifted tangent button is usually the inverse tangent. So inverse tangent of 4/5, and you'll get theta is approximately equal to, if I want 1 decimal place, all right, my 2 decimal places look 1 to the right of the one I want. It's 5 or greater, so I have to round up. So the answer I want is 38.7 degrees. And notice how I made a point of putting my degree symbol here, as I have everywhere I've had an angle measure in degree. If you don't put your degree measure, you're telling people that you're talking about radians. So be very careful to put your degree symbol when you're talking about degrees. All right, let's do another one of these. So in this example, it's the same idea. We're given 2 sides, and we want to find an acute angle. So now I've reoriented my right triangle just for fun. So it's still a right triangle. Everything's the same. I just want you to see it from a different orientation. So we've got 2 sides and an angle that we want to find. So again, your first step is to label these sides in terms of hypotenuse, opposite, and adjacent. So opposite the 90-degree angle is my hypotenuse. So now the hypotenuse is on the bottom. That's okay. It can be there. Opposite theta is opposite. And then the side next to theta, but not the hypotenuse, is adjacent. Okay, so we've labeled everything. The sides we know are the adjacent and the hypotenuse. So we're looking for a ratio or a trig function that uses adjacent and hypotenuse for the ratio. So it's going to be the cosine. So our equation will be cosine theta equals adjacent is 11 and hypotenuse is 15. So again, I need to get at theta. So I'm going to have to take the inverse cosine function of both sides. So theta equals the inverse cosine of 11 over 15. Plug it into your calculator, round to 1 decimal point, and you'll get 42.8 degrees. Okay, so hopefully that helps you find missing sides and angles in right triangles. Just a couple things. Remember, the right triangle can be oriented any which way, so don't be thrown if it's twisted from the way you're used to seeing it. All you're looking for is a triangle that has a 90-degree angle in it, and then you can use all of these techniques.